Great. We were waiting for you. So hello, everyone. My name is Andrei Diaconu. I'm here on behalf of Microsoft. I'm part of the Surface Duo team. More specifically, there's a team inside of Surface Duo that focuses on the experience that you guys have, the developers. We call it the Surface Duo Developer Experience Team, so DevX for short. I was, in the best case scenario, I was supposed to give this presentation next to Andrew Fitz Gibbon from the Flutter team, but because of how travel is these days, we have him in a virtual, let's say, version. So it's just me physically here. So I know it's a bit late for all of you. Well, not super late because it's not yet the party at the end of the conference. But I want to have as much energy to give you out of this presentation, and you are here to be informed, but also a bit entertained. I'm not a stand-up comedian yet, but maybe one day I will be. Until then, I would like to ask you if you want, and only if you want to participate, to make a bit of noise, even if it's just a small clap or like a eye roll that I can hear from here, for 3 simple statements. So this is my idea of an energizer. It's been 2 years since I participated in an in-person conference, so I really missed this part of the conference experience. So if you want to play this game with me, I'll just go ahead with my first fundamental statement. So pizza is good, if you agree. Yeah, okay. There. I was wondering if I should go with pizza because we're not in Italy, but you know, it's universal. London and DroidCon are fun. Okay, great. It's my first time in the city, and this is my first time at DroidCon. I've been an Android developer for years, so DroidCon, of course, is something I always wished I could join. And now I'm joining it as a speaker. I hope I'll do a great job for you. And London, of course, is fabulous. I love the city. And third, Flutter is awesome. Do you agree? I know that's a low-hanging fruit. I mean, you have to clap for that. Otherwise, there are other rooms dedicated to something else. I remember when I started Flutter about 3 years ago, and I was blown away by the speed at which the app refreshed with hot reload. Sometimes I take it for granted these days, but yeah, it's a very powerful tool. It gives developers power, and that's why I think I love it most, because it gives us power to do more. Okay, so you may have noticed that devices started doing different things lately. They started bending and folding. Of course, Microsoft is one of the devices. Microsoft Surface Duo is one of the devices. Samsung also has devices. There are many other device manufacturers that do all kinds of weird stuff. I've seen rollable displays at some point. Anyway, you may wonder how these devices or how these new functionalities translate for us developers. And I want to introduce a new term for us today. It's called display features. You're going to hear this term a lot today. So what all these devices have in common, if you lay them flat on a table, they are the same as a old classical candy bar phone. But what the features that they present and that make them special are called display features. And we'll go into detail a little bit more, but first I want to simplify this this notion. So the display features are the parts of the display that present a crease or some kind of fold, or even a part of the display that your application cannot actually render pixels on, which is the case for the Surface Duo. There are three types of display features: hinge, fold, and cutout, or at least these are the type of display features that we have today. We don't know 10 years from now. Probably we'll come up with some other device, I don't know. Let's start with the cutout. The cutout, I think, is you're most familiar with. Probably the phone you have in your pocket, no matter if it's Android or iOS, actually has a cutout at this moment. You've been dealing with it using Safe Area until now, so you're already aware of its existence, and you didn't need to do a lot of stuff to adapt to it. Just add a bit of padding, and that's enough. The fold is the display feature that you can find on the Samsung Galaxy Fold and the Samsung Galaxy Flip, which is kind of what that represents in the middle. And it's a part of the display that only presents a crease, but it's still an opportunity for your application to present a logical separation in the UI. And I'll show you examples of that in this presentation. And the one that we'll be focusing a lot more in this presentation, the hinge. I have a device here. I want to, at the end of the presentation, I want to invite you to install your application if you have any on the App Store, the Play Store, sorry. I want you to experiment with it. This is why I have it with me today, and I'll be available afterwards. So the hinge is a part of the display that your application needs to take into account, because there are parts of the display there that you cannot render pixels on because they don't exist. More on that a bit later in the presentation. There's a different or another term or concept that I want to introduce, which is called posture. So the posture is the name that we gave to the shape that the display makes when you're using it. And there used to be more postures in the past while we were researching and developing this product. But right now there are only two postures that you need to take into account. One is the flat posture, which is opening it all the way to the end. Oops, I opened the camera. Anyway, and the other posture is half opened. And you can view it as a mini laptop experience or a Game Boy experience. It comes really naturally to think about games when looking at this device. And there's a lot, there's a few things I can say about that as well. Before we dive into the specifics of how to adapt to foldable devices, I would like to take a few minutes to discuss the larger context of adaptive and responsive design. Because this device and the others as well, these are the first mobile devices where your application canvas can change at runtime. It used to be that your phone would be just a candy bar form factor, and you can't actually resize the app because the app occupies the whole screen. But because you can drag the app, span it, unspan it, and for the Samsung devices, you can close the phone and the app will show on the exterior screen, you now have a case where your application size can change at runtime. I'll do that a couple more times, I hope you don't mind. So to talk about responsive and adaptive design, I'll invite Fitz over, and he'll give you a primer on that. I know it's a video, and I know we want to have a physical interaction as much as possible. So bear with me for the next 6 minutes. Thank you.
All right. Hi everyone. I'm Fitz, developer relations engineer with Flutter. So we're building for multiple kinds of devices, multiple kinds of screens, and everything is different everywhere. And because of that, it's tempting to account for this programmatically. If we're on platform A, do things this way. If we have a screen that's of this orientation and this size, organize the widget that way. If we're on platform C, just throw it all away and do something totally different. This gets unwieldy, overlay complex, and hard to maintain really fast. And it presents a lot of questions. On platform A, screen sizes actually vary quite a lot. On platform B, we can resize and reorient the window. Or on platform C, maybe we have multiple screens with a hinge between them and a notch at the top of one or both of them. And so, unsurprisingly, we have some answers for this: responsive design and adaptive apps. These are sometimes used interchangeably, but they are different concepts. And here's how I think of them. So everything has a screen. I mean, that's kind of the point for UI frameworks, right? And putting them onto a screen in Flutter is more or less the same everywhere. This is a widget, and it should look like that. But wait, the window size has changed. Oh no, however will we respond? In responsive design, we respond to the changes in the screen or window size. We say, given that we have some number of pixels oriented in a particular way, where and how big should widgets be? Okay, that's great. Everything has a screen. Everything also has other things. Modern computers are more than just an arithmetic unit and some storage. We have some long-term storage, networking, sensors like GPS, barometer, temperature, heart rate, biometrics, peripherals like keyboards, cameras, microphones, secondary screens, and oh, so much more. And pretty much everywhere that Flutter can run pretty much has all of these. But while they're all the same in spirit, after all I want is a pair of lat-long coordinates, the exact details vary widely by platform. For this, we must adapt to ensure we're prepared for what might come. And with this, we've got a pretty clean separation of concerns: UI and presentation versus platform or device-specific functionality. In other words, how does it look versus what it does. In the presentation layer, we have a few tools to use. The first and probably easiest to use is media query. Given a context, it'll give you the size of the area you can paint to. Generally, this is the size of the window or screen and is your first indication of which layout to use. Got lots of pixels? Use more information. At a slightly lower level, you might have a situation where you want to subdivide further. Maybe your screen is so wide that it's not just about splitting it in half, but having one of those halves be split even further. To have this widget level control, there's Layouts Builder. Instead of the screen's size, this widgets builder gives you the constraints that its parent gave it. So you can put it anywhere in the widget tree and then make similar breakpoint decisions. And in some UI use cases, like scrolling physics or button ordering, you want to be able to account for platform conventions. For this, use theme.ofContext.platform. And it's not the only way to get to the platform. The isX constants in Dart.io.platform are frequently used, but we distinguish the two methods the same way I distinguish them here. Theme.ofContext.platform for anything that needs to show to the user, but Dart.io platform to account for platform-specific capabilities. And speaking of it, there's a lot of these kinds of capabilities you could be thinking about. Let's take a look at a couple of examples. Perhaps the easiest one to look through is URL Launcher. The API surface from the app's perspective is pretty simple. Here's a URL, please open it. There are at least a few videos on the Flutter YouTube channel going into more detail about this package, so I won't spend much more time on this specific one. Behind the scenes, it uses two concepts: federated plugins and platform interfaces. Federated plugins essentially just help with the development process. Instead of one giant package, you have one for the Dart interface used by actual apps and additional packages for each and every platform you want to support. Underneath those is some kind of interface between Dart and the platform's APIs. In many cases, this is what we call a platform channel, where Dart can invoke methods from Kotlin, Swift, or other languages. And in other cases like the web, the platform's code is called directly. Let's look at how this works in a real example. Geolocator. In the package's main code, there's just a single file with a single class, and it's pretty simple. There are a few methods for status checking, like if we have the right permissions, and then a few different ways of actually getting location that do nothing but delegate out to geolocator-platform.instance. And that's it. That's the code for this entire package. At build time, we look at the pub spec and we say, hey, we were asked to build for Android. Let's go get this other package too. That other package, Geolocator Android, is where you'll find things like Java code that calls out to Android's fused location provider. This particular code implements Geolocator's platform interface. And there's yet another package that provides that, the Geolocator platform interface package. Here's where that Geolocator platform.instance comes from. By having this platform interface package, the top-level Dart package can just say, for whatever implementation is available, give me the current location. And each individual platform package can implement get last known location using whatever tools and APIs that specific platform provides. And that's more or less it. By keeping these two purposes separate, you can avoid complex and messy if platform trees, but still respond and adapt to the various screens your users are on. Thanks everyone, and I hope you have a great rest of the conference.
Well, thank you, Fitz. So, to sum up, or to rather give to express the way I understand it, responsive refers to when your window size changes, you should adapt to that. And adaptive design is having the UI a bit tighter if you're on a desktop, or have the touch targets be larger if you're on a touch device. That's kind of the adaptive part of it. Of course, like you have the default app that you create when you make a new project that does not look like a desktop app. Well, I think it does now. They changed the default project, but the one with the fab in the corner, I've never seen a desktop app do that. So that's not an adapted design. It might respond to the window changes, but that's not the design you would deliver for a desktop client. So in that larger context, the challenges or the opportunities rather that you have on the foldable devices are of the responsive nature. And let's see what that actually means in code, because we've been talking more conceptual, let's say. I know you want to see the code. So this is the main thing that will change in Flutter. You will have a new property in display in media query. It's called display features. It's an array. It's an array because you can have a device that has a notch and also has a fold. It's actually the case with most foldables. They also have a notch because there's a camera cutout there. The properties exposed by a display feature are bounds, type, and state. The bounds refers to the rectangle area of the screen where the display feature is located. This might be the most important property because you need to figure out what to do with that area of the screen. The type can be a hinge, a fold, or cutout. This is an enum, so it will have new types added to it as new types appear. For now, there are only these three types. And there's a state, which can be flat or half opened. So you might be wondering how your app behaves on the Surface Duo, because having the hinge area, you might be a bit concerned, like, will my app actually not work properly? And apps by default open on one single screen, and they behave exactly how you expect them to behave and how you developed for them. There's nothing special you need to do. You should view the second screen rather as an opportunity. So it's more space that you can offer more functionality on. Users can also use two apps at the same time, and in native Android development, you can already drag and drop stuff from one app to another. And we on our roadmap, we also have that for Flutter. So we also want to add that as support for Flutter. So it will be coming next year. And this is, I think, the most important or the biggest difference between a candy bar phone and a dual screen device. You can span the app. So dragging the pill from the bottom to the middle of the device is called a span gesture. The app becomes spanned. In the spanned state, your app has access to the whole screen. The hinge area is transparent for your app, meaning that you can ignore it. It's not there for your app. Your application sees the entire screen area formed by the two displays. You do get the display feature in media query, which you will use to do something with that area of the screen. So it's important to note that these are not two separate displays for your app. It's just one single large screen. Okay, so let's see a few examples of apps that enhance to take advantage of the second screen. Outlook, which is a Microsoft application, shows a list of emails on the left and the open email on the right. And when you compose emails as well, you can use the right screen while you still browse through emails on the left. Outlook is also capable of showing emails on the left and I hope I'm not remembering this wrong, but there's the calendar functionality is also extended and enhanced to take advantage of the full screen real estate. A non-Microsoft application I would like to show you is the Jira application, where you can see the whole sprint or Kanban canvas, and you can drag items from one screen to the other seamlessly. The drag and drop, or rather the pointer functionality, is written at the driver level, so you don't need to do anything. Actually, even the OS sees, so if I start a drag gesture from this screen and go to the other screen, that's seamless for the operating system. It sees it as one single finger. The drag doesn't end at one screen and then restarts at the other, so you don't need to worry about that either. This is a cute example. I really liked it when I saw it the first time. It's the YouTube application. If you put your device in half-opened posture, it uses half of the display, or rather one of the screens, let's say, as a full screen experience for the videos. And it uses the hinge as a natural separation area for the UI. So the question is, how will you enhance your Flutter app? And what does Flutter do for you? So you have to do much less, or like what's included in this contribution to Flutter? So first, dialogues simply work. You don't need to worry about them. Normally they show up on the center of the screen. That of course would not work with the hinge, with the display that has a hinge. So by default, dialogues go on the left or on the right, depending on the directionality that you have set up in your app. So if this was a right to left UI, the dialogue would show on the right. So if it's in Arabic or something like that. If you want to pick the particular screen that you want to show the dialogue on, there is a new parameter to show dialogue called anchor point. And you should view this as a target that you put on one screen or the other, and the dialogue shows up on that screen. This is most useful, for example, in scenarios where you want the dialogue to show up on the same screen where the user interacted last with the application, because it would be a bit awkward to tap on something on the left screen and to see the dialog on the right screen, for example. So that's why it's more like a target. So you can write your code once to make yourself a helper function that gets the last interaction or something like that and shows the dialog on the correct screen. Also, pop-ups work. They just work out of the box. Context menus are pop-ups behind the scenes. Normally, this pop-up would show on the hinge, but it chooses the closest screen. It chooses the screen which contains its anchor, sort of anchor point, because a context menu is tied to a widget, and where that widget lies on which screen it's rendered, that's where the pop-up will show. So from our research, there are 5 big and main design patterns that kind of surface when working with the dual screen device. I'll quickly go through them one by one, but first I wanted to present you a different resource. It's not really meant for you, but it is meant for your team, because presumably you are all developers. I didn't ask, but maybe you're not. But you work inside teams that have designers, product owners, and we want to help the whole team as much as possible. So we also have a Surface Duo design kit. All these design patterns are present in there, and everything else you might need, like wireframes of the device and really common use cases, are present there, and we keep updating it. So you'll have links at the end of the presentation with everything that I'm showing to you today. But just if you want to try the device out, there's also an emulator that you can use, and if you want to have a discussion with the designer on your team, you can also give them something to work with directly. So first is the extended canvas. This is the one that's already working in your app. It's called extended canvas because it's a canvas that you can move around, which means that if something is below the hinge, the user always has the option to move it out of the hinge area. Meaning that you don't need to do anything for a map experience, for example, other than open pop-ups on only one screen, but the user is free to move the map around. Of course, if something is selected, don't put it in the middle of the screen. Just put it in the middle of one of the displays. So this is, of course, a very good example of this usage would be a map, but you can also imagine a Excel sheet or a Sheets experience where you have multiple cells. You can drag those around. And anything that really is a canvas, even a drawing app, like, I don't know, Paint, MS Paint, more specifically. This detail, I think, is the easiest to understand and the most common. I mean, the other ones are there as well, but this one is super versatile for most apps that I've seen. You have a list of items on one screen, and you have the opened item or details of the selected item on the other screen. Another one would be a 2-page experience, where you basically duplicate the type of content on the other screen, allowing the user to see more. It's not necessarily, I mean, it's a really nice experience to read on the Surface Duo, and the Kindle app already works perfectly on it. So you're just showing more of the same thing, let's say. And I'll show you examples of how to accomplish this in code as well. Dual view is a bit trickier to explain, but I think the image, if you look at it and you imagine this is a restaurant finding app, you have a list of restaurants on the left, but you also have the map with the same restaurants on the right, which is to say that dual view is a design pattern for viewing the same thing from different perspectives. Another good example would be a 3D editing app. I don't know if you ever used one or maybe worked with Unity or something like that, but they always have different perspectives, because if you look at an object from the front, it might seem like it's aligned, but if you don't look at it from the top, it may be misaligned with the rest of your scene. So 3D software would be a perfect example of this. You have a view from the front on the left and a view from the top on the right. So yeah, this is also very good for, yeah, I'll move on, I'll come back to this later. Companion pane. Imagine you have a photo editing app. This is the easiest example. You have content on one screen and you have modifiers on the other screen, or you have some supporting content, or even smart suggestions. To give you an example, when you onboard on this device, you get the typical experience of setting up your Wi-Fi, setting up your Microsoft account, your Google account, as you will with any other Android phone, right? But because it has two screens, one of the screens contains like the tools that help you get to the next step, so a Wi-Fi selector, but the other screen contains tips and tricks, like if your Wi-Fi isn't working, do this or that. Because it's an extra screen. At some point in your product design lifecycle, someone comes in and asks, how can we introduce some tips and tricks in the app? This is a good way of doing that. I'm not suggesting that's what you do, but that's also a possibility. So all of these design patterns are easily obtainable by using a new widget that we want to introduce. This widget spares you the process of going through if the device is larger than this, then do this. If it has a hinge, then do this. If it's taller than this, then operate like this. What I have on this screen is the exact same application, is just rendered in 3 different contexts. The first one is the Surface Duo emulator, which you'll have a link for at the end. The middle render is from a Nexus emulator, and the render on the right is a desktop macOS render. But you can also imagine that being a tablet design. So for a tablet, for example, if your application doesn't really make sense to split the screen right down the middle, then don't do it. Just have, if panel A is, let's say, like a menu. I promised I'll do that. So if panel A is like a menu, or it's not a very complex UI, you can have it occupy 30% of the screen on a tablet, but you can have it occupy a full screen, a full display on the Surface Duo. All 3 are obtained basically with this code. So I know this is it's a bit of a trickery here because I simplified it as much as possible to get the idea across. There's a bit more that you need to do in most scenarios, but there's not a lot more to understand from it. So there's a bit more to do in each widget itself. But TwoPane takes 3 parameters which are mandatory: pane 1, pane 2, and pane priority. Pane priority refers to which pane should I show, and pane priority can be pane 1, which means show me only pane 1, pane 2, which means show me only pane 2, and both, which means show me both. And we split that out so you can have your bit of logic here. I put it in line, but I suggest that you make a separate method which decides, depending on the screen real estate that you have, if you want to show only A, like we have in the middle, both, like we have in the first and the last image. So let's have a look at how that would be accomplished, like the design patterns, how those would work. The list detail is actually the same code. It's just that I changed pane 1 and pane 2. They are grid of images and image details. This is how the UI would look on one single screen. So if I unspan the app, I only see the grid of images. Now this is where it gets a bit tricky, but not a lot, is how do I get to the second, to the image details widget, right? You still need to have some kind of navigation inside your single screen experience. Anyway, the companion pane is mostly the same code, but I wanted to show you that this also helps when you change orientation. The same code outputs this result, so this you would need to write extra code to make this version work as well. And of course, I'm showing it in a flat scenario here, but what you need to imagine here is that it's in a half-open state. So you have the image at the top, and you have the controls at the bottom, making it a very natural way of using this companion pane design pattern. So we're nearing the end. I would like to recap or kind of drive home what I would like you to take home, let's say. So ideas to take home are, there are a bunch of design patterns that we carefully thought about, and they're there for you for usage. They're there for you to show to your designer or product owner for them to check it out, see if it makes sense for them. There is an emulator that we are giving for free. So there's an emulator for you to use, and it also simulates the postures and the opening angle and everything. It's very similar to the foldable emulator that you'll find in Android Studio. Where it differs is that it actually has a hinge. So it has the middle area, it simulates that as well. The foldable emulators that you find in Android Studio are more of a Samsung variety, so they do not have a hinge area. I invite you, or I'm asking you, to just download the emulator, spin it up, run your app, see how it behaves in spanned mode, and in most cases, you'll just need to make a few tweaks, because your UI will probably have some kind of structure already that can be split into two. So this is the QR code if you want to scan it for the docs. Just to recap, Media Query now has display features. Pane is a new widget that helps you with foldable design patterns. Dialogues and pop-ups work. The dual screen emulator is something that I invite you to use. We have a design kit. The Flutter documentation is as well at this link. And for people in the room that are not Flutter exclusive, let's say, we also offer support for Android, Web, Unity, React Native, Xamarin. We also have support. So anything you make apps with will be there to support you. That's actually our motto, or some version of that is our motto. So yeah, thank you. And we also have a Twitter account. Give us a follow. It's our way of staying in touch with you after this presentation. Now, I think we have 10 minutes until the next speaker needs to come in. And I invite you to test your app on the device, if you're interested. It's connected to Wi-Fi. If it's launched on the store, we can give it a look. I'll be here. Thank you.